Hello everybody. Let's discuss another question. This is a question I came across on my newsfeed, my Facebook newsfeed this morning. Okay, what we are given is a big circle with center OR and radius capital R, and a smaller circle with center OR and radius small r. The distance between the centers is d. Okay, OR this is equal to d, and the points B, P, and Q. They are points of contact. So BP is a tangent to the bigger circle at B, to the smaller circle at P, and AB is a tangent to the smaller circle at point Q. Okay, and what we need to do is we need to express AB, this length, look at this length, in terms of the length D, R, and R. We need to express the length AB in terms of R, D, and R. Okay, that's what we are supposed to do, and that's all what we are given. Okay, all right. I'm gonna need a lot of space, so let me just clear out these things. Okay, I don't need this. I don't need this. Okay. All right. Now, first of all, join OR with B. Then OR will be a radius to the bigger circle, so ORB is equal to R, and as a result of which, this will be a radius. Okay, this will be the radius, and since this is a radius and this is a tangent at B, ORB will be perpendicular to the line BP. Okay, now let's draw ORS perpendicular to AB. Okay, ORS perpendicular to AB. Then we will get AS is equal to SB. So basically AB will be equal to 2 times SB. 2 times SB. Okay, and as you can see, we may express SB in terms of R. We'll come back to that in a moment. Now let's join OR with P like this. Then this will also be a perpendicular. This will also be a perpendicular. Okay, all right. Okay, now let's join OR with B. OR with B. Now let's focus on triangles BPOR and BQOR. Okay, we have this is B, this is P, this is OR and perpendicular. This is 90 degrees, this is 90 degrees. Okay, yeah, this is equal to R, this is equal to R. This is a common side. Okay, so this will be equal to itself. These two triangles are right angle triangles in which a leg is equal to a leg and the hypotenuse is equal to hypotenuse. So these two triangles are congruent, as a result of which If this angle is alpha, this angle will be alpha. So if we have this angle to be alpha, this angle to be alpha. Okay, all right. Now let's focus on triangle BQOR. BQOR. So we'll get rid of this part. We just need the lower triangle. Okay, BQOR. Then let's see. Sine alpha is equal to R by BOR, R by BOR, as a result of which BOR is equal to R by sine alpha. We carefully note that alpha, since it is an angle of a right angle triangle, alpha will be greater than 0 degrees and less than 90 degrees. Okay, this will be an acute angle. All right. So this is this side. This is R over sine alpha. R over sine alpha. All right. Now let's shift our focus to the triangle BOR, O capital R. Okay. Let's look at this triangle. OR, OR, this will be equal to D. This is B, so this is R. And we've just calculated that BO small r, this is equal to R over sine alpha, isn't it? And let's look at this angle. The 90 degrees is somewhere over here. Okay, this is 90 degrees. P is somewhere here. This angle is alpha. So this whole angle is 90 degrees plus alpha. 90 degrees plus alpha. Okay. This angle, this whole angle. Okay, 90 degrees plus alpha. Now what do we do next? We use cosine law in this triangle. We use cosine law in this triangle, which means we get cosine of 90 degrees plus alpha is equal to R squared plus R squared by sine square alpha minus D squared over the product of twice the product of these two sides, so twice R over sine alpha. If you multiply the numerator and the denominator by sine square alpha, cos 90 degrees plus alpha means minus sine alpha. Okay, multiplying numerator and denominator by sine square alpha, we're going to get R squared minus D squared sine squared alpha plus R squared all over twice R sine alpha. We're multiplying this by sine square alpha and this by sine square alpha. Okay. All right. Now on cross multiplication, we're going to get R squared is equal to how much is this? R squared will be equal to R squared plus R squared minus D squared sine square alpha, and this will give minus twice r sine squared alpha, and taking this to this side, we're going to get plus twice r sine squared alpha is equal to 0. So sine squared alpha is equal to r squared over the negative of the additive inverse of this quantity, which is d squared minus r squared minus twice r. Sine squared alpha means this needs to be greater than 0 and less than 1. Is it so? We don't know it yet. Okay? If it is not so, then why waste our time? Why do we waste our time? But we're not wasting our time. Let's see. First of all, show that this is greater than 0. Okay, greater than 0. It suffices to show, since r squared is always positive, it suffices to show that the denominator is positive. We have okay, d was, what was d? D was OR, the distance, this distance, isn't it? D. Now, let's see. OR, this point. Let's call it S means T, and this, let's call this U. T is somewhere over here, and U is somewhere over here. This is capital R, this is small r, and let's say this is S. Then D is equal to R plus S, and S, since S is greater than 0, this entire quantity will be greater than R plus R. Okay, R plus R. So what we have is D squared is greater than R plus R squared. Okay, R plus R squared. This will be equal to R squared plus twice R plus R squared. Again, since R squared is positive because it's the radius of the smaller circle, it's always positive. Okay, so since this is positive, we get R squared plus twice R, which means if we take this to the left side, we will get D squared minus R squared minus twice R will be greater than 0. So this is greater than 0. Okay, this is greater than 0. We've shown that. Okay, now we are going to show that it's less than 1. To show that it's less than 1, it suffices to show that the denominator is greater than the numerator. Okay, so this is done. This is a done deal. Again, what we have is D squared, sorry, D is greater than R plus R, because this is ORT is R and this is R. This will give us D squared is greater than R plus R squared. Okay, R plus R squared, and this will be equal to R squared plus twice R minus plus R squared, and if we take this over here, we're going to get D squared minus R squared minus twice R is greater than R squared. So the denominator is greater than the numerator. So not only this is less greater than 0. This is also less than 1. Okay, this is also less than 1. This is also less than 1. All right. Okay. R squared and okay, we need cos squared alpha. The cos squared alpha is equal to cos squared alpha is equal to 1 minus sine squared alpha. So this is 1 minus sine squared alpha, which is equal to 1 minus r squared by d squared minus r squared minus twice r, which is equal to d squared minus r squared minus twice r minus r squared all over d squared minus r squared minus twice r. Okay, this is it. Now if we look at this carefully, this is r plus r whole squared, so d squared minus r plus r whole squared, sorry about this, and d squared minus r squared minus twice r. Okay, this is it. Now as d is greater than r plus r plus r, this is greater than 0. Okay, this is greater than 0, upper part, and as we have shown, the lower part is already, this is already greater than 0, this part. Okay, so yeah, this is greater than 0 and less than 1, because d squared minus r squared minus twice r is greater than d squared minus r squared minus twice r minus r squared, because r squared is positive. This is nothing but d squared minus r plus, I hope you can see, r plus r whole squared. Okay, r plus r whole squared. So this is less than 1. So this also makes sense. So we can write, since alpha is between 0 and 90 exclusively, since 0 is less than, alpha is less than 90 degrees, sine alpha and cos alpha, they are positive. So sine alpha will be the square root of this much, which is nothing but r over the square root of this thing, the denominator, and cos alpha will be equal to the square root of the numerator. I hope you can see, over the square root of d squared minus r squared minus twice r. Okay, sine alpha and cos alpha. We need these values. We do not need anything else now. Okay. Asal with me. Okay. Okay, where was I? Oh, come on. and sine alpha and cos alpha. Yeah. Now let's see. We claim that this angle is twice alpha. Okay. We claim that this angle is twice alpha. We see that we have A, B, and Q. Okay. And we have from B, this is an angle alpha. There's another angle alpha. Okay. This goes to OR, this goes to P, and here's OR. This is 90 degrees. So alpha, alpha, twice alpha. So this is equal to 180 degrees minus 90 degrees plus twice alpha, which is nothing but 90 degrees minus twice alpha, right? This angle is 90 degrees minus twice alpha, and we needed this angle BORS, this angle. So since this is 90 minus twice alpha, this angle will be twice alpha. Okay, now we shall simply express SB in terms of R, D, and small r. Okay, we're going to do that. Okay, it's like what's up? Hit it on it. Nice. All right. Let's see. I hope you can see SB in terms of R, D, and alpha. Okay. OR, S, B. This is 90 degrees. And this is R. And SB means this is twice alpha. So SB by OR, B is sine twice alpha. Opposite side by hypotenuse. Okay, sine twice alpha. Then SB is equal to ORB, means it's equal to R. So R sine twice alpha. So this is equal to twice R sine twice alpha. This is 2 twice R times sine 2 alpha, means 2 sine alpha cos alpha. Now this is 4R sine alpha, means R. The numerator of sine alpha has R. The numerator of cos alpha has square root of this thing, square root of d squared minus r plus r squared. Okay, and the denominator of both sine alpha and cos alpha, they're same. Sine alpha and cos alpha, they're same. So the product of these two denominators will be whatever that is inside the root, but without the root. So d squared minus r squared minus twice r. All right, we've expressed AB in terms of R, D, and R. Okay, so it involves only D, R, and R. D and two R's. So we can stop it right here, but To make it a little more nice, let's write it as r squared over r squared plus d squared minus r squared plus twice r plus r squared. What I did is I added r squared here and subtracted r squared here. Okay, took minus 1 as a common factor to obtain this, and this is nothing but for our r square root of d squared minus r plus r squared. The numerator is not changed, over r squared plus d squared minus r plus r whole squared. Okay, all right. That's all about this question. We've expressed AB in terms of R, D, and capital R. And yeah, I think that's clear to all of you. Thank you very much.